My name is Elmar Fuchs. I work at the Wetsus Center of Excellence for Sustainable Water Technology. It's a European Center of Excellence located in Leeuwarden in the Netherlands. And there I work as part of the research management team, which is responsible for the direction of research which we're doing there, but I'm also heading the applied water physics theme, where there's a group of companies and researchers dealing with the fundamental properties of water and more precisely with the interactions of water with electric and magnetic fields. In 2005 or 4, when I was still working at the Graz University of Technology, my former boss, Professor Charlie Gatterer, one day came to me and showed me a video he had found on the internet with the water bridge, and it was a video by the ETH Zurich, Switzerland, for graduate students as part of a show about the interesting, peculiar properties of water. And we were both fascinated by it and thought we should try this and see whether this is actually working or if it's a trick. So we reproduced it. This was the first water bridge, and then we contacted the ETH Zurich and asked them about papers and information and background and explanations. Well, it turned out that they didn't have any. They just knew that this was a very old experiment, but they didn't have any references. So in the first paper, which we later on published about the water bridge, we referenced it to the ETH Zurich, and a couple of years later, a researcher from Seattle told us that this was actually an experiment first discovered by Lord Armstrong in 1893. And then it took quite some time and digging to get it from microfilm from some archive, but we found it, and that was the actual discovery of the water bridge. We have had the possibility, and this is quite unique, I think, to compare water to water. And in contrast to other treatments which might or might not do something to water, the water bridge has the fantastic advantages of looking peculiar, so everybody sees or there's something going on. It's quite stable. It's free hanging, so you don't need a container if you want to do spectroscopy. And with all that, we could get access to international beamlines like neutron scattering, X-ray scattering. We got people from the experts of the field interested in that. Last but not least, also Jerry Pollack, who, because of this paper, invited me to the first water conference, which was then the catalyst which set other things and other connections in motion. And because this is something you can see, and many people, when they look at it, think, oh, there's something to it, let's investigate it. And we've believed that for a long time, and we didn't have any proof that the water in the water bridge was different on a molecular basis from bulk water. But that belief in the beginning was enough to get us access to beamlines, experiments, specialized knowledge on water, so that in the end, we could profit from all that, and actually we were lucky enough to find out that it's true, that on a molecular scale, water bridge water is quite different from bulk water. And since we know that, well, we have a foundation for our research and justification to explore this new state of water. The interaction force between the water molecules is enhanced in the bridge. It's actually stronger than in liquid water at any temperature, but it's not so strong as it is in ice, because then it would be a solid and it wouldn't be a liquid bridge. And the force is actually in between the phase transition between liquid and ice, because we directly measure this strength, this hydrogen bond strength. And when you have the phase transition, there's a jump. First there's a continuum from liquid water, and then there's a jump with a no man's land of the forced bond strength where water doesn't exist in any known state, and then there is ice, because in ice it's much stronger than the liquid, because we know that when you freeze water, it's not becoming more and more viscous, not strongly, and then suddenly, and then slowly becoming a solid. No, this is a jump. It's either liquid, and then suddenly it's solid. And the water bridge is a state that's just in between in the phase diagram, meaning that with change of temperature or pressure, you can't get water into that state, because otherwise it would have been known for a long time. You need an electric field and a current in order to access this gel-like state of water. So we measured the protons that flow through. We measured their mobility inside of the bridge. And interestingly, what we found, and what we think, if our interpretations are correct, is that there are two populations of protons, one of which are very immobile and strong, so holding more or less the bridge together or contributing to that, and the other population is much more mobile than in liquid water, and this is close to the property of the solid phase. For example, in ice, you have proton conduction bands and proton valence bands. It's because it's a crystalline structure. You have these energetic bands, and the protons move like waves. And in liquid water, you don't have that because you don't have long-range order. You don't have that structure. It's changing too fast. And in the water bridge, you might just have something in between, locally small proton channels appearing. So it's not like it's one crystal, otherwise it would be a crystal, but they're inside a few water molecules form a connection which allows the protons to travel as a wave across a distance that's roughly twice as far as the protons travel in normal liquid water. This is an extremely important conference in my opinion, because Jerry Pollack manages to get together scientists from both the conservative side of science and from the non-conservative, perhaps more crazy, but without meaning that badly or without accusing anybody of anything here, but people thinking or claiming things that are really outside the current paradigm. And now the interesting thing happens when these two worlds interact, and this happens at this conference, when the crazy ideas are sorted out and are tested and discussed by the conservative traditional scientists, so that the real progress in the sense of, oh, there is something new which we hadn't thought about, emerges. And that is only because if only conservative scientists meet, it can be a very scientific meeting, but there's little progress normally. If only the people meet who are outside the paradigm, they're without foundation, and it's difficult for the ideas to be tested, to grow, to find any confirmation. But the interaction enables that the small percentage of crazy ideas, which are actually just crazy because we don't think that they are possible, for these ideas to become part of the reality and then part of the actual scientific community.